All right, so this is our eye model. Now, if you have your lab sheet out, the structures that we're going to be looking at on the eye model start with Activity 2, Internal Anatomy of the Eye. The structures that are mentioned above that in Activity 1 would be definitions, and you'll have to watch my PowerPoint presentation for that information. So Activity 2, Internal Structures of the Eye. The eye has three layers, or what are referred to as the tunics. So the fibrous tunic is the outer layer of the eye, and that's going to include the sclera, the cornea, and then we're not really going to talk about the limbus. But the sclera is the white of the eye, what people think of as the white of the eye. So that's this entire layer here, okay? Now if we just turn this way, you're going to be able to see the cornea. So the cornea is the clear, convex front of the eye here. The cornea is the structure of the eye that takes the light rays that hit the eye, and because it has a convex shape, in other words, it bows out, it takes those light rays and it bends them or refracts them, and it directs them into the pupil. And you can see there the pupil, which is the hole, okay, surrounded by the iris. I'm not going to worry about the limbus, okay? It's just, limbus is just the border right here between the sclera and the cornea. The next layer, the middle layer of the eye, is called the vascular tunic, okay? Now, the vascular tunic, okay, which means the area that has blood vessels. I'm going to take this cornea off so you can see some of the structures a little more easily. Here is the iris. Everybody is usually familiar with the iris of the eye because it is the colored part of your eye, okay? Now you don't need to know the pupillary constrictor muscles or the pupillary dilator muscles. The iris is basically a muscular ring. Okay. Its function, besides to give you pretty eyes, is to allow more or less light to enter into the interior of the eye. So the pupil is the hole, of course, through which the light goes. But when you're in situations where the light is very bright, the pupil gets very small, okay? So in other words, it constricts, and that's controlled by the iris. And when you're in areas of low light, okay, the pupil gets much larger or dilates, and again, this is controlled by the iris, okay? If we turn this model around, you're going to see a structure in the interior of the eye that looks very similar to the iris, and it's kind of set up the same way in that it's a ring of muscle. And this is the ciliary body right here, okay? Now, this obviously goes completely around, okay, in a circular structure. And what you see right there is actually the lens of the eye. I'm going to come back to that in a minute. So the ciliary body here, okay, actually holds on to the lens of the eye, and it allows the lens to do a particular special function that I'll talk about in just a minute, okay? And then if we just look at the rest of the model, anything that's in pink is the rest of that vascular layer, and this is called the choroid, okay? So the pink layer is the choroid. If we move on to the inner layer, or the inner tunic, that is what we call the neural tunic, okay, or the retina. Now, on our model, the retina, or the neural tunic, actually comes in two different colors. So if you look at it from the side, this yellow represents the retina, but so does all of this orange here. And again, you see the word neural, okay, in its name, which means it holds the neurons, okay, and the cells and the receptors that basically allow for vision, all right? So those receptors are what we call photoreceptors. A receptor is named after the type of information that stimulates it. It's stimulated by light. Light is made up of photons, and so these are photoreceptors. So the photoreceptors are the rods and the cones. Rods detect dim light of all colors, and cones detect bright colored light. And you have cones for red, blue, and green. All right? So those are all found on the retina. Okay, your lab book has a very good picture of the way the rods and the cones are set up. You don't see it here on the model, of course. To point out some other structures that are mentioned here, okay, I'm just going to turn this a little bit. Right. The optic disc is an area on the retina where there are no rods and cones. Okay, so here's the optic disc right here, this yellow half circle. And then this is the optic nerve. Now the optic nerve is made up of the axons of all of the ganglion cells, and the ganglion cells are part of the retina. You have ganglion cells all over the retina, okay? And all of those axons come together in this one spot, and those axons leave the eye via the optic nerve, okay, cranial nerve number 2. And these are eventually going to become part of the optic chiasm. Okay. The macula lutea, okay, is located on the retina. It's the area that's actually directly behind the pupil, so the light's going to come through the pupil this way, and it's going to hit this spot right here. You can see a tiny little divot on our model that represents the macula lutea and the fovea, the central pit. That's where you have your best visual acuity, or your highest concentration of rods and cones, and your best vision, okay? You have rods and cones throughout the entire retina, but you have most of them right here. So that's where your lens wants to focus the light, right there. So let's go back to the lens. So here is our lens. The lens is directly behind the pupil, okay? So when the light hits the cornea, it gets refracted, it gets sent through the pupil, and the cornea does about 66% of the refraction of the light. The rest of the refraction of the light is done by the lens. And what the lens wants to do is it wants to focus that light right here at the macula lutea. So the lens has a special ability to grow either thicker or thinner depending on how far away an object is that you are looking at. Okay? Because the light rays that hit your eye from something that you're looking at across the street are a different length than the light rays that hit your eye from something that's right in front of you. And so the lens does what we call accommodation, which means it can actually get thicker or thinner in order to focus those light rays right there on the macula lutea. What helps it do that is the ciliary body. The ciliary body holds onto the lens, and it can either relax or pull on the lens and change its thickness so that the lens can accommodate. Now, while I've got the lens here, I'll just mention cataracts. Okay, cataracts are a disease where you get a protein buildup on the lens that makes the lens cloudy. Perhaps you know an elderly person who's had cataracts and had to have surgery to remove the lens and have it replaced with a little plastic lens. This can happen to animals as well. They actually do cataract surgery on dogs and cats now. All right, so that's one of the diseases that I always mention, the cataracts, which is the buildup of protein on the lens. Another disease I always mention is macular degeneration. So if we go back here again and look at the macula lutea, macular degeneration is simply exactly what it sounds like. This area of the eye begins to degenerate or die, and when it does, it affects your vision. Okay, and because your best visual acuity is here, it can really lead to a big problem. You can become legally blind from macular degeneration. You tend to lose your central vision first, okay? And then that area of vision loss becomes greater and greater until you really only have peripheral vision, okay, which makes it, impossible to do things like read and watch your television and so forth. It tends to happen mostly to elderly people, okay, but not always. And then the last disease that I'll mention, okay, is glaucoma. Now I'm going to take the cornea and I'm going to put it back on this model. I'm going to talk about the chambers and the cavities. All right, so if we turn this guy sideways, on your sheet here it mentions the posterior cavity and the anterior cavity of the eye. So the posterior cavity is anything behind the lens. So from the lens to the back of the retina here. So this entire area, or what they call the globe of the eye, is the posterior cavity. That is filled with an opaque gel-like substance. It's called the vitreous humor. Okay. The anterior cavity is anything in front of the lens, and that's filled with what we call aqueous humor or aqueous fluid, and aqueous fluid is clear. Aqueous fluid, okay, exerts a certain amount of pressure on the eye, and when you go and you have an eye exam and they take that little puff of air and they puff it against your cornea, they're measuring the intraocular pressure, which should be somewhere between 7 and 12 millimeters of mercury. If that pressure becomes too great, either because you can't get rid of the fluid or for whatever reason, that's one of the types of glaucoma, and that can lead to pressure on the capillaries in the eye, okay, which can eventually lead to blindness. So again, glaucoma is when you have, one type of glaucoma is when you have too much pressure in your anterior cavity, okay, and it can lead to glaucoma, which can lead to blindness. So that's our eye model.